The console is useful for testing, but we really want to start seeing something happen in our actual speed meter. First, we want to change the speed value to 0. Click on the text object, and in the attribute editor we scroll down to text and change 220 to 0. Back in the logic editor, let's delete the console node. Then if we go to our scene outliner, grab the text object from the previous lesson and then drag it into our graph. A node will be created with the name of the object and a single output labeled object ID. This, when combined with other nodes, allows us to manipulate our scene objects within our logic. Because we want to change the text within a text object, let's add a node called setText. Another way we can create a node is by pulling an output pulse onto an empty part of the logic graph. This will then give us a pop-up box where we can search and locate the setText node. This will create the node and the pulse connection. You'll see that this node takes two data inputs. One is the object ID, which tells the node which text object to set the text of, as we want to set the speed text. Let's connect this up now, and the other input is of the string data type, and it's called text, which we can connect our add node output to. Once again, a conversion is created, and Incari also adds pulse connections to the correct places. Now, when we press play and then press up, the text is now being updated within our scene. The next thing we are going to do is increment our value every time the up key is pressed. To do this, let's first create a new variable, and let's call it increment_step. And that will also be of the int data type. This variable will define the amount that the value will increase and eventually decrease. By saving this in a variable, as opposed to changing it on the add node itself, has a lot of advantages as projects grow in complexity. You will often find yourself referencing the same data in several places and having a global value that affects every instance. Where this variable is used is much more manageable, as you only need to change the value once. So let's set the default value to 1. And reset the default value of the speed value variable to 0, since we want to start counting from 0. Then drag it to the graph and select Getter. Now we can connect the new variable to the second input data socket of our add node. If we press play and then press up, you'll see that something isn't working, as one may expect. No matter how many times we press up, the text stays at 1. If we go back to our logic and investigate, we'll see that we are getting the value of our speed, but we aren't updating the variable to the new value once it is incremented. So to do that, if you remember from earlier, we can drag the speed value variable to the graph, and this time select setter. Unlike the getter, this node has an input data socket, which allows us to dynamically change the value of our variable. So before we convert the value and set the text, let's update the variable. To do this, you can drag the node over the pulse connection, and before you release the left mouse button, hold Control. Now the node was added between the two nodes. To plug the output data of the add node into the speed setter, we can Control and left-click the data input socket of the conversion node and drag it onto the input of the speed setter. The output value of the setter is the same as the input, so let's just plug that into the conversion node. And now, when we press play, we see that the value is being incremented correctly. Also going to quickly set up the logic for the down arrow key press. So to do that, I can click and drag to select all of these nodes and then press Ctrl and D to duplicate them. Then I'll drag them down here. Delete the add node. Then create a subtract node because we want to decrease the value. Set the data type to int, and then we'll just fix our pulses and connections. And I also need to change the key attribute on the on key pressed node to listen for the down key. And now if we play this, you can see that the value is increased and decreased, depending on which of the up and down arrow keys is pressed. In the next step, we will be reviewing our logic and seeing how we can improve it through optimization, decoupling, and variable events. Let's get started. You may have noticed the problem starting to form in our logic. While functionally this works exactly as we want it to, the logic itself is not optimized. The logic in its current state is going to give us two problems. First of all, if we want to add something after the text is set or modify something in the existing logic, we're going to have to do this twice, because we have duplicated logic. Secondly, in terms of performance, we want to make every attempt possible to minimize the amount of logic in our project. Because these are the duplicated pieces of the logic, we should merge these into a single branch. So let's select these nodes here and delete them. And then remove the connections between add node and speed setter, which we can do by Alt and left clicking on a socket to clear all of its connections. Now let's move this into the center and add a new node which is called select data. What this node does is takes multiple pulse and data connections and outputs the data which corresponds to whichever pulse socket was fired. For example, if I connect the add node pulse and data connections to the top two sockets of the select data node, and the subtract nodes pulse and data connections to the bottom two sockets, what this will do is output either the increased speed value or decreased speed value depending on which key was pressed. So let's connect this node to the speed setter and then press play. Now you can see that we have exactly the same result, except we have much less logic. Another thing to be mindful of is that nodes relating to different aspects of the logic should be kept separate from one another in our logic. For example, we have one block here which deals with changing the value of our variable based on a key press, and another block here which updates the text in our scene to reflect the variable's value. At the moment, our project is small enough that we probably don't need to disconnect these, but in the next lessons, we are going to be adding more functionality to modify our scene assets based on this variable. If we continue going along in the line, things are going to get pretty hard to manage also. If something doesn't work along this chain of nodes, it's very possible that all subsequent logic will also break. That is why it is good to separate or decouple logic, so that the functionality of one aspect of the logic isn't dependent on separate unrelated functionality. So let's decouple this now, so that we separate the getting and setting of our speed variable from the updating of the speed text. Now you're probably wondering how this logic will ever be fired, as this is no longer connected to an event. Well, if we drag the speed variable onto our graph, we see that one of the options it gives us is on change. If we select this, we have a new event listener, which is fired every time the value of the variable changes. So if we connect this up, we have now successfully optimized and decoupled our logic. If we now press play, nothing has changed as far as the outside world is concerned, but the underlying logic is more performant and can be easily built upon. So now that we've optimized and separated our functionality, we are in a very good place to update the rotation of our needle graphic, which is what we will be doing in the next video.